Alright, so let's pick this up on the other side here. Let's look at a couple more practice problems, and the objective here is to look at some other curveballs with factoring that you may not have seen before. Like I said, I've talked about this in class many times about the big three. This one is definitely not one of the big three, but you can use one of those big three factoring jobs to help with this one here. This is one of my favorite types of factoring problems. When you look at this problem here, x to the fourth minus 3x squared equals 4. First step, make sure we set it equal to 0. Now let me just put a hypothetical here. Let me cover up the rest of this stuff here. Hypothetically, if this problem did not look like this, and it looked like this, x squared minus 3x minus 4 equals 0. Okay? Definitely exaggerated that. But if I made this a quadratic and that was still a minus 3 and a minus 4, could you come up with two numbers whose product is negative 3? I'm sorry, product is negative 4 and their sum is negative 3. Well, sure you could. X times x would give us x squared. We could write down minus 4, and then if we add 1, that would put us at negative 3 with the product and the sum. So in other words, this quartic polynomial here can actually be factored the same way we could factor a basic quadratic. Let me backtrack here. And that's essentially what they're trying to get you to see right here. They try to do this whole substitution maneuver here, and they say, well, let's let a just represent x squared. So instead of x to the fourth, if we let this be x squared, it's kind of like saying x squared squared. So they say, hey, see that x squared right there? Let's just say a. So now I have a squared minus 3a minus 4. So notice that if we did that, I'm still looking for two numbers whose product is negative 4 and their sum is negative 3. That's why you get these two guys right here, a minus 4 and a plus 1. Since we let a be equal to x squared, now would be a great time for us to replace those a's that we just had there with those x squareds. Now, in the case of this blue one right here, that's a difference of two squares, which you could factor as x plus 2 times x minus 2. However, with this yellow one right here, there is no factor method for a sum of two squares, so we have to leave that one alone. So with the zero product property, we have x plus 2 times x minus 2 times x squared plus 1 equals 0, which leads us to those answers there, which they kind of skipped through, so I'll kind of write it over here. Blue, blue, yellow, right? So either x plus 2 could be 0, which means that x could be negative 2 when you subtract 2 from both sides. If x minus 2 is equal to 0 and I add 2 to both sides, now I get a solution there. Now because x squared plus 1 could be equal to 0, I could subtract 1 from both sides, which then would put me in this position. X squared would be equal to a negative 1. And in the previous lesson, we learned that the square root, to solve that answer, we take the square root of both sides, and the square root of negative 1, as we can see right here, they put that in the text, the square root of negative 1 would be I and negative I, plus minus I. So there's all 1, 2, 3, 4 solutions right there to that quartic polynomial. Okay? So let's take a look at this guy right here. First thing we should do, set it equal to 0. So our first move, let's subtract 16, and so now I'm going to have x to the fourth minus 16 equals 0. If, and only if, what if this thing here just said x squared minus 16? Wouldn't that be a difference of two squares that we could factor? Well, sure. The point is that if it's a quartic polynomial, we could use some quadratic techniques to help us solve this guy. So let's factor this almost like it's a difference of two squares, which essentially it is. And we have x squared times x squared to give us x to the fourth, and 16 is a perfect square, and we can accomplish that factor job pretty easily by putting a plus 4 here and a minus 4 right there. You got two options from this position here. You can either continue to factor here. I'm not going to make that a major requirement to continue to factor. If you want to just set blue and yellow equal to 0 and solve each one individually, have at it, mates. We can say that x squared plus 4 could be equal to 0, and let's go ahead and solve that one. subtract 4, and uh-oh, look what happens here. We are going to get x squared being equal to a negative 4. And so then when we take the square root of both sides to solve, now I'll have x being equal to not only a positive 2i, but a negative 2i. Because we're taking the square root of a negative number, we need I in there, don't we? Okay, so now we move on to the other one. Okay, so x squared minus 4 could be equal to 0. Let's add 4 to both sides. So that would make it positive 4. Now we can take the square root on both sides. So then x would be equal to a positive 2 and a negative 2. So I have 4 answers there. Wait, you only see 2, don't you? Remember, the plus minus creates 4 answers. One answer is 2. The other answer is negative 2. Another answer would be 2i. And the other answer would be negative 2i. Those are our 4 solutions there. Okay, let's factor this one, see if we have any real or imaginaries here. Do you see how the leading factor, the highest degree, x to the third, see how it's positive, it's on the left side? It might be a lot faster to subtract the x cubed and put it over there on the right side, but I don't know. I just like having the leading coefficient be positive, that positive one like right there. Let's keep it positive. So let's go ahead and add 2x squared, put it over here, that side of the equal sign. Let's subtract 8x, put over here on this side of the equal sign. Let's write this in standard form, so we'd have x to the third, followed by plus 2x squared, and then followed by a minus 8x, and that would be equal to 0. First off, before you try any factoring tricks right here, what trumps all of them is greatest common factor. I think we can do greatest common factor here. I think we can factor out in x, can't we? So let's factor out the x. And if we do that, x times an x squared would make x to the third. X times a 2x would make 2x squared. And then x times a negative 8 would make negative 8x. Okay? Not off the hook yet with the factoring. We could set this equal to 0, or maybe we could continue to factor that. Now, guess what? If we could not factor that there in blue, and even if we could factor that in blue, do you guys understand that the quadratic formula, a being 1, b being 2, c being negative 8, is always an option if you are struggling with the factoring side of things, if it's quadratic? You can't do it when it's cubic, right? Cubic formulas and stuff like that. Save that for your abstract algebra class in college like I had to. Really fun. Now, what you should do here, though, is understand that you have, at this point, a potential to factor that there in blue. So let's copy down the x. It's already factored out. Do I have two numbers that multiply to negative 8 and add up to 2? I think I can do it. I think I can do it with an x plus a 4 and then x minus a 2. Foil it to check. First and first is done. Last and last is already good to go. It's the outer and the inner. So that would be negative 2x plus 4x would give us 2x right there. Fantastic. Okay, now it's time for that 0 product. Wait for it. Property. Okay, three things multiplied together to give us 0. So doesn't that mean that x could be 0? That's the blue guy. Guess what? We're finished. Okay. Don't we also have the fact that x plus 4 could be equal to 0? Solve that one by subtracting 4 from both sides, and we've got our second answer. Okay, and then x minus 2 could be 0. Here's our third and final answer of 2. Okay, great. Let's take a look at some more problems on another video in the playlist.